Hey guys, it's Mist, and welcome to a tutorial on how to build some solid state RAM. But before we get into building it, I need to show you how the design's going to work, and that way you'll better understand what each part does as we build it. I plan to build 8 bytes of RAM with you plus the decoders, so it'll be the full setup. And yeah, let's get into it. So the way this RAM works is, or at least the register here, it acts like a D flip-flop, but what it does is whenever you input something, it makes an infinite loop. Therefore, it's just a solid signal. And then right here, we've got a read function. And as you can see, when I turn on the read function, you'll notice that there's only one signal strength here. And that's because if I had a bit over here, it won't interfere. So that means I can keep the read wire very small. And then back here, I've got a comparator repeater. This repeater is just to make the barrel stuff very easy. So keep the repeater. You'll need a subtraction mode comparator and a normal comparator just in compare mode. And the reason why is because when we have dust coming in the side, it'll do a compare, but since that one's less than this, it's not going to change anything. So that's why it's compact. The target block is used to redirect the redstone signal because that comparator here wouldn't be powered if I didn't have the target block. And so what this comparator's job is to do is set a signal strength of 14, so just non-stackables with one missing slot. And it does 15 signal strength minus the 14, and we get a 1 signal strength. So if you look on the middle right, you'll see power, and the power is 1. And that's what allows me to make the read function super small. And so let's go ahead and test that. So if I input a number here, and also this is the write function, so I'll explain what the write function does right now. It unlocks the input so the input can go in, and it also cancels this infinite loop, so it subtracts 15 from there, which causes this to go to 0. So watch that. So it goes to 0, but then when I unflip the lever, it unlatches that, and it unlatches this at the same time, but this comparator has a short delay, so it just sets in the value at the right moment, which causes it to set in the value. And if I set a 1, we get a 1. Or, I mean, if I set a 0, we get a 0. So I'll go ahead and just use a lamp to help indicate that. So yeah, we can write a 0, we can write a 1, and we can read the 1 and zeros. Now, right now, with this system, this is the interesting part. So even though this has a 1 in it, it acts like a 0, so it's inverted. So when we build our busing, we're going to have a redstone torch at the top to first invert the signal before it goes down. And now I'll show you why. Because by inverting it, it allows us to use the read function more properly. So let's put it in the inverted one, and watch this. Boom, we can read it now. And now if I put a 0, get a 0. And that's it. So that's basically how it works, and now we will get right into the action. Alright, so we're going to start with one block. And the first thing we need to do is put a target block here because we want that part to redirect in. You're going to need this comparator on subtract. You're going to need this one just going up. And this will complete a loop. Some of you will be familiar with this if you do hex memory, but we're going to treat this as a normal binary memory just for the sake of making it easy. And so there we go. We got that. And now the next step is getting our comparator to change the signal strength down to 1. So I'll go ahead and just put a barrel in. I don't like the barrel facing that way. I like it facing this way because it looks nice when the target blocks are there. Okay, so now go ahead and grab a non-stackable item of your choice. I'm just going to grab these two, and I'm going to fill them up nicely. I'm sure some of you will understand what that's about. Okay, now that we got our 14 signal strength, you could check on the right middle section. There's power 14. So we got that. And now we're going to face it this way. And yeah, now we're going to build that and just go up 3 because it's going to tile by 3. So do that. And that is the base part of our memory done. Now we just got to go ahead and add a repeater, dust, block, and this will just go down right into here, and it will lock that comparator during the rate function. And then right below, we're going to just extend that out, and that's it. So now we've got the complete unit here, which is great. But before we do our tiling, we are going to need to do that. So there you go. So that'll be the read bus, and this is the write bus. So everything should be nice and easy to do. And now we're ready to use World Edit magic. If you don't have World Edit, I highly suggest you watch a tutorial to get it. It's very easy. Trust me, and it's worth your time. If you don't want to use World Edit, you could try using structure blocks, but they're still a pain. Or you could just build it by hand. And I'll show you where you would want to start and stop your stacking. Okay, so the first thing we're going to stack is the register itself. We want 8 bits of it to get a byte of RAM. So let's go ahead and do that. All right. And now I will just go ahead and do a stack. Doesn't matter which way you choose. We'll just stack this way. Why not? And there we go. And yeah, so later we're going to decide where our write and read is going to go. Or we can even do that now because it kind of matters. So yeah, let's go ahead and do that right now. So what we'll do is I'll have the write on this side, as you can see. Did I forget? I think I forgot something, guys. Here, 1 second. I know I've forgotten something. Let me just double check. Maybe I didn't. I'm probably just tripping out. Yeah, I am forgetting something. There you go, redstone torch. Sorry about that. Yeah, we would have been absolutely wrecked if we didn't get that. All right, beautiful. So that's that. So what we'll do is we'll get our write wire on that side, and our read will just go here like that. And yeah, we're gonna need a repeater here. That's okay though, because this torch won't even belong here. We're gonna have a decoder here later, so it'll all work out. And that's, yeah, so that'll lock the rate later on, so don't worry about it. And now the read will just be a repeater right there, and then we can test if it reaches. It doesn't reach, so we gotta go in 1 block closer, which is perfect. Yep, very good. And there we go. So now we've got our main register here. Very simple. Now you could further optimize this by removing torches in certain spots, but I'm not going to do that. And yeah. So let's just go ahead and take a pause one up on this corner. And the size doesn't really matter too much. We just need to get the pause in there. So pause 2. And then we're going to go ahead and copy it right here. And basically, if you were building this, this bottom part would be starting up here. So when I paste this in, you'll kind of see why. So we just have enough room to put a repeater and to have the wire underneath get under there. So, and also the reeds are perfectly 45 degrees. And now we're going to just stack this 6 more times to get our 8 registers. So it's as easy as doing paste minus A. Yep. And I'll just double check right now. So 1, 2, 3, 4, 5, 6. 2 more. 7 and 8. And believe it or not, that's 8 bytes of RAM. Or a register bank, however you're using this. I don't know how your guys are using yours, but anyways, so yeah, we got that all under control now. So the final step is to, well, there's a couple things we'll do, but the next step in our process is to build the decoders. So let's go ahead and do that next. Okay. So to build the decoder, we're going to need 3 bits because we can get a value from 0 to 7, which is 8 numbers in total, which will be useful. Now I am going to make some extra room here because I want 1 more wire. And this wire right here is going to have the purpose of doing the read or write function because we're going to copy and paste this addressing on the other side as well. So yeah, that'll be fun. But it's going to look this wide, and yeah. So now I am going to add the next few things we'll need to make this stackable. So we'll stack down, of course. So we're going to need a slope like this. And there we go. And yeah, torches will go here. And whenever we need a repeater in our decoder, it just goes like so. So it's very convenient. We might as well put these blocks in and we could just break them whenever we need to. So yeah, there we go. So that should do it. Very cool. Let's go ahead and get this going. So we're going to take a pause one there, or yeah. Just need to mark the 2 corners there, and then we're going to copy right here. And then we're going to want to stack, well, we're going to paste them in because it's a little easier. I don't think there is a normal way to stack diagonally like this, or at least I just don't know a good way to do it. That's what it really comes down to. So I'm just going to walk down, paste minus A is just for safety, and yeah, it's pretty much that easy. There we go. Oh, and of course we got missing, oh, it's not missing blocks, it's just redstone dust being silly. Now we're going to go ahead and make sure that we got enough signal strength, because that's the next thing I usually do. And yeah, we're going to want to do it up here just in case if we need a redstone torch there. So let's go ahead and do that. And I think it's only 1 repeater. Yep, very easy. It's like really nice. Oh, and these don't need the bottoms because we're not having to represent those. Yeah. Okay, Now, one thing we can do legitimately here is put redstone torches on all of these gray blocks, and then we're going to paste the empty decoder on the other side so that we can match the numbers correctly. So go ahead and add the redstone torch here. And now we're going to take a pause. One and a pause 2 up here. So pause 2. We're going to copy. And then facing into this block, do a / flip. And all we have to do now is give us some room. I think we should get as much room as we could possibly get here because it's very convenience is a good thing. And yeah, very unoptimal, I know, but you could do a better job. I know you guys are really smart. You could do a better job than this. So yeah, I just don't care about optimal stuff right now. It's just about functionality. All right, here we go. And there. And the reason why is because this is the right wire, and we don't want the right wire to be deleting our data all the time. So that's something we got to take into account. But now it's time to do the fun part. We get to actually decode the decoder now. So this line is 0. So what we're going to do is we're going to place repeaters like so. And to make this easier to decode, we are going to do a binary pattern. So since this is the ones place, because we're going to do 1, 2's place, 4. So what we're going to do is we're going to do 1 there, skip this, 1 there, skip that, 1 there, skip this, and 1 there. And that is half of the ones done, and now all we have to do is just run back up with the repeaters in the spots where there isn't a torch. So right here, oh, not there, right there. See that? It still works, so that's cool. And there. And that's that. So we did the ones column, and now we're going to do 2's. Now for 2, you're going to start with 2 repeaters on that bottom block. And now you're going to go ahead and do 2 here. Skip 2. And then another 2 here. And then go on your way up with your repeaters. Come on. 2. And that's it. So we're done with the 2's column. Very easy. And now for the 4's, this is probably the easiest one because we just need to add 3 more repeaters, which has a total of 4, like so. And then we're going to go ahead and add 4 torches. And now this is effectively a 3-bit decoder with an enable line. So I'm going to go ahead and do this. We have to test it, you know, it's just a part of the thing. And we also have to see how far that signal strength goes, which it goes all the way. Okay, so as you can see at line 0, it's like 0. If I add 1, it goes to 1. If I go to 2, it goes to 2. And then 3 goes to 3. And as you can see, it's a very fast decoder. 4 goes to 4. 5, 6, and then finally 7. And so there you have it. It all works beautifully. And now we're going to repeat the decoding on the other side, which is great. Oh, and by the way, whenever you're doing the right function, make sure that it's done on the falling edge or something, but it's only going to need to be a pulse because we're just allowing the number to set, and then that's that. Okay, so now we're going to go ahead and decode this side, and we're going to do it the exact same way we did it on that side. The reason why I couldn't just copy and flip it is because the number would flip. And I wanted to make sure it's not as confusing. So I'll start our zeros like before. And let's get our ones in there. Every other block. Or yeah, every other Y rather. By the way, you're always going to have ones down at the bottom. Oh, I already messed up. Oops. That is not good. Let's just switch those sides real quick. It's not a big deal. There we go. Easy. Now, yeah, we gotta pay attention here. So let's go ahead and add our repeaters. Every other. As you can see, there's that. No torch, torch, and no torch, and torch. Okay. And now the next one was 2, like that. And then we just had the 2 repeaters. And then just another 2. Like so. And just another 2. And there you go. And 4 is the easy one, so let's just add the 3 more. And then the torches. And there we go. And now we've got our second decoder, and we want to test it just to make sure it matches basically the other side. And the read is going to be a solid signal on because we need it to read more often. So yeah, so as you can see, the read just unlocks that, and right now we just have all these on because that's what value we had set. And there you go. The next one, the next one, and the next one. And I think you guys get the picture. It goes all the way down. I mean, it's a 3-tick decoder at max, so it's not too slow. So there we go. Cool. So that's it. So we've got our decoder built, but there's one last thing we can do before we actually have fun with our there's actually 2 things. We need to complete the repeaters here, and then we can also get the bottom bus repeated up, and then we'll be good to go. Oh, my bird landed on me. Yeah, you can probably hear him in the background, so yeah. Yep. Let's go ahead and turn these all on, because before I showed you that we needed them inverted. So that's actually very useful for doing the next part here. And I'm just getting levers on all these because we'll want to do some fun tests at the end here. So, yep, we're going to go down. And we're going to place the repeater here so that we can still receive power down there. And it'll also reach. So, yeah, everything's good. So let's just go ahead and do this. Okay, and now it reaches all the way down. And let's go ahead and get the bottom done. And the first thing we're going to do is trim these blocks off because we only needed them to do the pasting. So there you go, trim them down. And then right here we've got all of our torches on, or not on, but they're off. We'll turn one on so we can figure out how far we have to go. It looks like we have to go till this block. So what I do is I take a repeater underneath the busing, and I use a... I don't usually use a slab, but I'll use a slab here just for you guys. And you need 2 of them so they could do a little tower. And basically I'm going to repeat this for the other parts so we could just do a nice stackaroo. Also, you don't need that redstone dust there. Okay. And now that'll continue its signal. We can remove those just to keep the redstone lag down, as you know, just a little bit. And there we go. That's it. And this is the RAM. So congrats to anyone who made it this far. I mean, if you left, you got the world download. Yeah. Anyways, But yeah, actually knowing how to build something's better than just having the world download. Anyways, now we can go ahead and add some indicators, and we could do some tests, you know, because you have to see that it does work. I'm going to go ahead and rate a 5 to address 7. Oh, that's not the rate function. This is the read function. Yeah, that's the read. This is the rate. Well, rate to address 7. As you can see, everything's up in the front. The input, output, everything. So it's really convenient. Okay, so I've written to address 7. And now I'm going to rate 225 to, like, address 2. And then I'll rate 42. So that would be this one, that one, and 2. I'll rate that one to 5. Yeah. Okay, cool. So I'm going to go ahead and put some indicators on the bottom, and that way we could do the read function. And I'll remove these so you know that it definitely saved in there. And now, let's go ahead and read 7. So the read function happens when we do that. And there we go, we got 5. And then if we go to address 2, we got 225. And if we go to, was it 5? I can't remember. Yeah, 42. And there you go, it works beautifully. Very easy. So this is your enable read function. And then this is the rate function. So, yeah, I hope you guys enjoyed the tutorial. If you did, give it a like, subscribe. You know I'm gonna make more. Oh, and this is for horizontal. Now, if you want vertical memory, there's a lot of tutorials on how to do that, but I might also make a tutorial on how to build that as well. All right, cheers, guys.